I should. It's probably not. Okay, so let's see here. If I need, so that would be point number 1 that we just identified. Point number 2 would be where it repeats the pattern again. How far to the right do I need to go before I find where it starts over again? 2 pi, right? On the cosine wave, the third point is located in the middle, so if I come back to the middle, I have to go down to the bottom of the wave, which is 1 point below the center line. Remember, the center line is running right through here. And then point number 4 is easy to find, and point number 5 is easy to find because they're halfway between the other ones. So there's my 1, 2, 3, 4, 5. Thank you. And then we do our best to connect the dots. So once you find your HK, you go up to find the first point, over to find the second point, halfway in the middle, and down to find the third point. And of course, we could probably identify all the other stuff, domain range, min, max, but that's going to be pretty similar to what you saw yesterday. Okay, try this one. So, hopefully you understood that we were dealing with the reflection. Reflection across what? Well, okay, which axis? That's the straight one. Okay. Oh, gee. Cracking me up, kid. Okay, center line still here. HK is still there at the origin, right? Vertical shift and phase shift. But now, which way do we go to find? I mean, we got our amplitude at 1 and our period at 2 pi. Which way do we go from that HK to find the first point? We go down, right? Because it's been reflected. How far to the right should I move before I find a place where it starts over again? 2 pi. Right? Because you're moving using the period of the function to move over to find point number 2. Okay? Halfway in the middle, where do I go? I go up. And then 4 and 5 are easy to find because they're halfway in between. So we have our reflection. Okay, so try this one. So there's HK. What do we do to find a point somewhere nearby? Do we go up? Do we go down? We go up in this case, right? Whoops. Why is that locked in here? Okay, how far to the right should we go to find another place where it starts over again? 2 pi, right?
Wait, which one's HK?
HK is sitting right there at 0, 2, right? Your vertical. Sorry, I did that backwards. 0 should be my phase shift. 2 should be my vertical, or negative 2, I should say. So that's the point, 0, negative 2. Okay, so halfway in between, where do I go? Yeah, I'm at pi. What do? Do I put a dot right where I'm at right now? Do I go to the center line? Do I go to the bottom? I go all the way to the bottom, using the amplitude to go underneath. And then, of course, I have dots in the middle, and so I can draw the rest of my wave. Not always. So far it has been. Oh, yes. Oh, yes. 0, -2 is the HK, but you have to go up from the center line to find the first point because it's a cosine wave. Yes. Question.
Sorry, but for the negative cosine, what was the HK?
That was 0, 0. Okay, because there'd been no shifting left and right and no shifting up and down. Let's go to 5. I know my center line is, and I'll get to the amplitude question here in a minute. I know my center line is still there. Where's HK again? 0, 3, okay? Actually, it's 0, 0, okay? It has not changed. HK is still at the location 0, 0. There's been no shifting left and right, no shifting up and down. The only thing that we've had going on here when we look at it in fireproof form is what? A vertical stretch by 3. So, since I know I'm dealing with a cosine, and I know that the first point sits above the max, how far up do I need to go before I find my first point? We could trace it or we can draw it. I don't care which we do. But yeah, 3. Okay, so the amplitude has been stretched. It used to be a 1, but now it's 3 times larger than that, which I'm really hoping would be easy multiplication. Okay? How far to the right should I go before I find a place where it starts over again? 2 pi, because the period has not been stretched or shrunk. Halfway in between. All right, so we went over this way to find our, then we're coming back for point number 3, and how far down do I go? Do I stop right there? I stop right on the center line? No, I keep going until I get the amplitude all the way down to the bottom of the wave. Right? We have point number 1, point number 2, all the way at the bottom we have point number 3. What's the question? Okay. Because the wave does, if this is truly, if the blue dotted line is truly the center line of the wave, you have to have points on both sides that are matching distances away. So the distance from here to here is 3 units, just like the distance from here to here is 3 units. I can't stop at the center line, otherwise it's not called a center line. The only reason the amplitude is 3 is because it got stretched. You're right. And then, of course, we have points in the middle, the 4 and 5, and we can draw our wave. And we're doing the best we can. Try not to be the kid that does this. Okay, try to give it it's not some kind of absolute value thing here. Try to give it a little bit of curve. Okay, I know we're not artists. I mean, some of you are. I'm not, but. Okay. Yep. The HK was 0, 0 because nothing. There wasn't any. When we have y minus k over b, there was nothing that was being subtracted or added to the y. And on the other side of the equal sign, we have cosine, oops, I forgot my S. Cosine x minus h over a. There was nothing being subtracted from the x or added to the x. So there's been no shifting left and right or up and down. Let's go find one of those. Probably towards the bottom of this worksheet. All right, we'll do number 7 and then we'll find your center line first. What's the center line of the wave? It is 2. Okay, so everything should be centered on that 2. Skip what? Because I didn't think that we needed to do a duplicate type of question. I'm just doing enough examples so that you have different types. You can go back and practice them if you want to practice them. Okay, plus you could use Desmos.com to check your answer to make sure you're right. Okay, so if you just want to make sure you're doing it right. Okay, so when we put it in fireproof form, we see a 1/2 here. What does that mean? Vertical shrink by 1/2, which is going to change what? The amplitude. What's the period? Still 2 pi, right? There was no scale change on the horizontal. All right, see if you can graph it. Where is HK? Right there at 0, 2. There's your HK. Zero for the phase shift, 2 for the vertical shift. That might help you. Okay, so from HK, how far up do I need to go to find the first maximum value? 1/2 of a unit, which is going to be about right there. I only went up 1/2 a unit from HK. How far to the right should I move before I find another point which is in that exact same location? 2 pi units. So we should be duplicating, we should have an entire cycle between those 2 dots. Right? Because we used the period of the function, 2 pi, to get all the way over there. That will be another top, another maximum value. Halfway in between. Okay, where do we go? Is it the high value, the center line, or the low value? It's the low value, which is 1/2 a unit below. And then periods, or the 4 and 5 points, are the easy ones that are halfway in between. So we get that real shallow looking cosine wave. Any questions on that one? I know that, yesterday we had HK and it was actually one of the points on the sine wave. Now we're talking cosine, so it's underneath a maximum value. All right, let's jump down to number 9. Number 9. What's the center line of this wave? It is 0. What's the HK location? 0, 0, right? There's been no shifting left and right. No shifting up and down. When I looked at this, I had to realize that in fireproof form, that's the same thing as dividing by 2. So what's going on? This is what? A horizontal shrink or stretch? Stretch. Because that number is bigger than 1, right? You have to look at it in the denominator to understand the shrink or stretch. So what's that going to change? It's going to change the period. We know that the period used to be 2 pi, but we're multiplying by the absolute value of a, which now makes it 4 pi. Because we're doubling it. We're making it longer. So see what you can do about graphing that one. Yes? Favorite number? My favorite number? I've not ever really... I do like a lot of the numbers. A lucky number? No? Let's see if I can come up with a good answer for that. Radical pi would be pretty cool. Totally irrational, but pretty cool. Radical pi? Radical pi? I mean, come on, it's a radical and it's pi? Stresses you out? Well, I can't choose any of the complex numbers because Apple trademarked them all. Like 3i and 4i and 5i, you know, Apple's got all those, so takes out the the imaginaries. Probably get sued if I chose one of those, you know. What? Well, that's a good one. That's a good one. 85 is a good one too. 54, that's a good one. 50, yeah, 50, 51, those are nice ones too.
I know what these years are.
These are Chicago Bears jersey numbers. So, yes. 40 is a good one too. Yeah, I am a little bit unimpressed, but you'll catch up. You'll catch up. It's true. That's good. All right, now to continue on here and see if you're correct. The amplitude was 1. It was not affected because there was no vertical stretch or shrink. So when I've located HK, I move up until I find the first point, which is above the HK. And then I move how far to the right to find a place where it starts over again? Ooh, 4 pi, right. Because it was stretched. And then to find the third point, I come back to the middle and do what? I go down to the bottom of the wave, which is using the amplitude to go on the opposite side of the center line. And then, of course, the easy ones where they sit on the center line. And then we can draw our super long curve. What? Yeah, no, you did good. Okay. Okay, now, on question 10, you will be given a question like this. Y equals cosine 2x. Now, the reason I'll scroll down here in a second, but I need you to understand, just like we talked about yesterday, 2x over 1. Some of you are going to get really confused about what is going on with the horizontal direction here. So I've got to remind you, in the fireproof form, we only have 1x. So what would you multiply 2 by to make it turn into a 1? 1/2. The reciprocal. But we have to do the same thing to the top and to the bottom. So if you have multiplied by 1/2 to the top, you must multiply 1/2 to the bottom, which gives you what down here in the denominator? 1/2. Okay, now, that's how we got this fireproof form. You have to be able to do that so that you can realize what's going on with the horizontal. Shrink or stretch? Shrink. By what? 1/2. You need to be able to do that simple little algebra thing so that you can see it. All right? So we got that. What's the center line of the wave? Still y equals 0, right? That center line has not been shifted. HK, where's that at? Still 0, 0, right there. Okay, see if you can handle. Since we did a horizontal shrink, what is the period? What is half of the period of the old period? 1 pi, right? If 2 pi was the original, and you cut it in half, you would be at 1 pi. Amplitude? Still 1, right? Because we did not change the vertical, only the horizontal. Okay, see if you can graph it. Hopefully you got a picture that looks something like this. You used your amplitude. You went up to find the first point. You used your period to come over pi units to find a place where it was starting over again. Halfway in between, you went all the way to the bottom of the wave, which was 1 unit below the center line. And then you found your points in between. Okay, suppose this is part of question 12, okay? Suppose you were given this equation, which is probably how it's going to look. I need to understand what's going on. So help me put it in fireproof form. What do I do first? Add the 1, okay? Now what? Divide by 3/2. Now, if we use that trick we did a few minutes ago, and we want to go from 1/2 x over to 1x, what are we going to multiply by? We'll multiply the top by 2, and we'll multiply the bottom by 2. So what does that denominator become? What? 2. So what's going on here? Let's find my center line. What's the center line of the wave? -1. If you can see everything without changing it to fireproof form, okay. Not everybody can. If you can, then okay. I'm okay with you being able to identify everything in this without doing that. So, you just told me the center line was -1. Has there been any shifting left and right? That would be right up here with the x. No, so the phase shift is still 0. So my HK is sitting right there at the point 0, -1. What is my amplitude? Amplitude, something to do with this stretch down here. 3/2. If you're a decimal fan, obviously that's 1.5. Okay, whichever, I don't care. What's the period of the function? 4 pi. How'd you get that? You took the stretch You took the original one and you stretched it. Now, I heard you over there. You're doing Math Excel stuff, aren't you? Ah. Yeah, you were. Yeah, but it's true. I don't like to think about it like that because that confuses a lot of people, but it still does work that way. Okay, so with that information, graph your picture. Why is it doing that? Up 1.5 over 4 pi. In the middle, I come down 1.5, and then put my middle points in there and graph my wave. Now, you notice we haven't done any phase shifts yet? We will. Monday.